Okay, I don't know what's happening, but the thing keeps coming on and off. But here we are, here we are, here we are. The thing is coming off and off. Maybe the cost. So, like I was saying, the T start here. This T start is like the null hypothesis versus the alternate hypothesis. Actually, it measures the departure of the estimated parameter from the hypothesized value to its standard deviation. So, like I've said, and there is also the Z start where the, the observation is more than that. So we come to the p-value, and this one is the probability of the hypothesis, isn't it? Yeah, this one like how likely your data would occur in the null hypothesis, isn't it? The probability of the value, the probability value. And here we have the confidence level. So we have the lower 95 and we have the upper, isn't it? The lower and the upper. And here we have been already been given the confidences, isn't it? So, and here you can come and see that the residual output here, you've been given the predicted y, isn't it? There is a question that you plot the predicted y against the actual y, isn't it? And maybe what else? I don't think there's something else. So we shall just answer the questions directly. Okay, so the first question is determine the variable cost per unit and the total variable cost using regression analysis. So we have already done the regression analysis. So we are looking for the variable cost, and I say that you see like y is equals to a plus b plus x. So b this one is our variable cost, and a is our fixed cost, and y is our total costs, isn't it? So it will be like, and we identified where they are. Isn't it? They are here. This one is our variable cost per unit. So here the variable cost per unit, variable cost per unit, I'll do this way, equals to this one here, control enter, control backspace to jump to the active set. Then I'll put it in cache, isn't it? So that one is the variable cost per unit. And so you've been asked determine the total variable cost. So here also the question was not specific, like the total per month or the total per the whole total. So we'll do the whole total, isn't it? So the total per month, it will be the variable cost here. So here, variable cost equals, so it will be our quantity here, this one, and I want to log it F4 times our quantity sold, isn't it? Control enter. So that is our variable cost, isn't it? So I'll come here, I do alt equals, control enter, control bold, isn't it? Alt HBP for top board. And that one is the total, like the total for the year, isn't it? This one's our total variable cost per month. And let me say we also have the fixed cost. So equals, I'll say that our fixed cost is this one here, and I lock it, and I do control enter, and I do enter, isn't it? And I take it down. So we'll find that equals this one plus this one, control enter. This one is now the expected y. I think it's down there, but expected y, control enter, control board. Isn't it? You can see that there are a very deflections. You can see from the 36, and this one is 37, 18, and this one is 18 to 25. There's some variations. So that's why we are plotting x versus, let me see, y versus the total, the expected y versus the actual y, isn't it? And you interpret your answer. So like let me see, like, so you have already done here, determine the variable cost per unit and the total variable cost using regression analysis. So we'll go to estimate the total production cost if the following numbers of units were produced, isn't it? So here, and I include the lower and the upper boundary. So here it will be like lower 95% tab. The estimated is not actual, estimated, and the upper 95 shift percent tab, isn't it? And you must know that confidence interval, this one is just something small here. Confidence, let me write this, confidence interval equals to what? Confidence interval equals to margin of error plus shift plus or minus the expected value or the estimated value. If you remember under management accounting, actually this one does not relate to here, because here what we will do, it will be this way, very simple, very simple. Let us answer this question. So we start with the lower. Here you are given already the lower 95, and this one is just a repetition, of the table. It's the same. You can see the up and here, it's the same thing, So y is equals to, remember that's our equation, isn't it? A. So our upper here, it will be this one. Our lower, the A will be this one here. So let me start with equal sign. Let us do here equals. So our A here is that for the lower 95 is this one, shift plus. So B times B times the, so these 100 units, it's the units, so we just write 100, 1, 2, 3, isn't it? And I'll do this way. Control board, Alt HBP for top board, isn't it? And I'll do this, let them be in cache, isn't it? So that we can read them properly. So actually this one is the lower limit. So the expected here equals, you come here, just here I told you this is our A. So A plus B times 100,000. 1, 2, 3. You can see up here. A plus B times 100,000, the number of units. Control backspace to jump to the active set. So this one is the estimated one. So we are looking for the upper boundary equals. So we were given upper 95. That's why we didn't want. So the upper is here, a shift plus this one here, our variable here, this one times times 100, because the 100 is the 100. 1, 2, enter. So here you can see. So for 100 units, we have our lower interval of 95 at 10 million. The estimated is 13, and the upper limit of 17. So we can do the same thing there. I'll do this way, control C. And I forgot to lock, so I can just come in the here. I lock here. I also lock this one. I do control enter first, isn't it? So that I just have to change the value. So when I come here, I do control C. I come here, I do control V, and I press F2, and I edit 150, 1, 2, 3, enter. I come here, I copy this one, control C. I come here, control V, and I also edit, I F2 to edit, and I say 200, 200, 1, 2, 3, enter. So also I come here. Okay, this one here, I never locked, so I lock F4 so that they don't move. That's the essence of locking. Control enter. So control C, then I do control V, then I do also control V. I come here, you will like have 10 minutes. I come here, this one. I lock first, F4 to lock, and F4 to lock, control enter. Then I control C, then control V, then control V. Isn't it? So I just come to change the values here, like here. I click F2, I remove that one, I write 150, 1, 2, 3, enter. Also here, I can change from here up. I remove the 0 here, I do 5, and I do enter. I come to the last one here, I remove the put 2, I do enter. I come here, I remove this one, I do the 2, I do enter. Isn't it? You can see that Alt HBM to remove the borders, because they are, and then Alt HBP. Isn't it? You can see that we have included the lower and the upper boundaries at 95 confidence interval. You can see it was just as simple as that one. It was just as simple as that. And you can just measure like equals this one, the estimated, minus this one, control enter. You can see 36, okay, equal. This one here, minus this one here, control enter. It's more than that, 45. But normally, the confidence interval should be equal, because from the like they should be equal. That's what I know. I don't know, maybe there's something. And you can see also for the 200 units, actually I think here we finished. And so like you can see here under our graph here, that's why we are putting in the line of feet. Let me move down. Let me move down here. I'll do this, I'll expand it. You can see that actually y versus the predicted y here. Actually, it's almost everything is falling in, but just a few because of the variances. So the few will be because of the variances. Actually, that is the interpretation. There's no other interpretation, right? And so we will come to this simple one here, so that you understand more of the confidence interval. So estimate the lower and the upper confidence level or limit, isn't it? So here you can see that our sample size is below 30. Below 30, it's 25. So here we will use the T1. So for the T, like the good thing of Excel, you can just calculate directly what is it called? The margin of error instead of calculating first, like it's always like this way. I think I did it somewhere here. It's plus here, but I no, so the margin of error here, I'll do margin of error. Margin of error here, it will be like equals to, so it will be the mean, so the mean can be, let me say, x shift plus so the t, so for the t start, isn't it, for the t start, but I'm not doing now the t distribution, but actually the t distribution is there. This is the long format. So this T is like a representative. Let me use this one. The big T is like the representative. And so for the T start, or we can use the Z. Also, we have it in Excel, the Z start. So it depends. This one is returns returns the wanted p-value of and this one I say is the probability value of the Z test. So and the value here must be more than 30, isn't it? So plus, so it always like the standard deviation. So the standard error. So the standard error is like this one is not sigma. So this one is like times. This one is the long format of students, like normally how they were doing it, times the standard error. So the standard error is S over the square root. I don't think the laptop writes, so over the square root of n, isn't it? Like it will bring an error part because of the word square root. Like this one I tabbed in it. So like it's taking it as a square root. So actually that is the long formula. Let me do the square root. Oh, sorry. I started with the equal sign, so it was confusing it. So this one is the margin of error, how to find the margin of error, isn't it? But here, now we will be using an Excel formula known as the confidence. You write confidence T here. You can see returns the confidence interval for a population mean using the student's T distribution of T statistic, isn't it? So this one is below 30, the sample one. So you press tab. So the alpha will be 1 minus the confidence level, isn't it, to press comma, and the standard deviation you've been given here is 18, press comma, and the sample size is 25 here. You close your brackets, you do control enter, isn't it? And you can just reduce the decimal places. So this one has already given you the confidence, the margin of error. That is the margin of error. So for the lower limit, it will be equal to the sample mean minus, because it's the lower limit, minus that one, enter. And for the upper limit, it will be this one, the mean, plus the margin of error. Control enter, isn't it? And we have like 2 minutes. And today we shall stop from here because actually the lesson I had not prepared it earlier now. So we're just doing something on regression analysis. Actually, that was what was important. And this one is just for the confidence level. And assume that now the sample size is 100, and so you can see it's above 30. So like when you say, like when the sample size increases, the like it's assumed it's like a normal distribution. it's assumed to be like a normal distribution, the mean. So here we'll use something called equals, which is confi norm, confi norm, isn't it? So this one returns the confidence interval of a population mean using a normal distribution, isn't it? Because when they like we always say like when the sample size is 30 and above, that one's a large sample. And when it's 30 and below, it's a smaller sample. And we have said when the sample size is large, the distribution is assumed to be a normal distribution. Press tab. So under here we've been given a 99% confidence, isn't it? Press comma. Standard deviation we've been given here. Press comma, and the sample size is here. You shift, you close your brackets, you do control enter, isn't it? So that's the margin of error if here equals this one minus this one, enter, and here equals this one, shift plus this one, control enter. I think now you have just understood the basics of confidence interval, so you can actually relate to what we've been doing. Sorry. And this one to be in 2 decimal places, and it's yeah. So that one is the upper and the lower limit. So and that one is what we did here, but Excel had already done for us these ones, the lower and the upper limit. It was just a thing of multiplication. So thank you for today's class. I'll see you in the next class.